Hello friends, welcome to my channel. Let's have a look at problem 2447. Number of subarrays with GCD equal to k. In this video, we're going to share a solution that is roughly brute force but mimics the DP solution. First, I'll read through the statement and then we do the analysis, and finally we share the straightforward code. First, the statement. Given an integer array nums and an integer k, return the number of subarrays of nums where the greatest common divisor of the subarray's elements is k. A subarray is a contiguous non-empty sequence of elements within an array. So the GCD of an array is the largest integer that evenly divides all the array elements. So that's the definition here. So here are two examples. So in example 1, so the output is 4. For example, 3 as a single element subarray divides 3, right? The largest common divisor is itself. So similarly, the second valid subarray. The third one is 9 and 3. So these two elements have common divisor GCD. So let's see, 3, right? Similarly, 6 and 3. So the output is 4. So in the second example, so the numbers list has length 1, right? So there's so 4 and 7 actually is relatively prime, so mutually prime. So their common divisor is 1. So the output is 0. So here the constraints are the following. First, the nums array has a length bounded below by 1 and bounded above by 1000. So this 1000 is actually very small. So if we consider the square, it's 10 to the power 6. So it's still doable in this case. So the second one is that so the elements in the list and the k is not negative, actually strictly positive, because they are greater than or equal to 1, and it's bounded above by 10 to the power 9, right? So with that said, we are ready to do the analysis. Here in this video, I will not elaborate too much. So here what we are going to do for the treatment is that, so for each subarray starting from index I and ending at index j, so we are going to compute the GCD, right? So in the process, actually we can do the counting. So this requires on squared time n, where n is the length of this list. So we could mimic the way we do DP actually. The reason is the following. So due to the problem definition of the GCD of an array, so we can do the following observation, right? So if we computed so a number of a GCD for a certain set of numbers, or for certain list of numbers, let's say ai plus 1 or up to aj, then we could get the GCD. So let's call the former GCD as d, right? So we can get the GCD if we add one more number, say aj plus 1, by computing the GCD of the previous GCD, that is d, with the current number aj plus 1. That's it. So as the logic is very simple, so we directly do the coding. So here we see the logic is very simple, that we assume that our audience know how to compute GCD or how to write code to implement the GCD function, right? So with that said, let's see the coding. So for the this is actually very routine. So first I'm going to get the length of this list just for convenience, and then I'm going to, let's say, initialize a DP table. So here I'm using in square space just to demonstrate the logic. So n for range n. So here I'm using initialization by 1, right? So here I'm going to initialize a result variable, which is used for counting. So in other words, the final state of this result variable is the number of valid subarrays. So now it's basically for loop, or you can see if we want to use DP terminology, that is DP update rule. So we are only concerning about the case that J is greater than or equal to 1 to I, right? So for I in range M, right? So let's first do this. Let's see, for I in range M. So first I'm going to set dpi to be nums I itself, right? Because these are single element subarrays. So I want to check if dpi equals k, right? So we are going to increment this result by 1, right? So next we are going to consider the generic case. So for I in range M. So for J in range, so from I plus 1, then ending at M, ending at N minus 1. So we write N here, right? Because the right end is not included. So the update actually is very simple. So dpij is nothing but math. So let's use math GCD function. So dpi and j minus 1. So this dpi j minus 1 means the GCD of the subarray with starting index I, ending index j minus 1, right? So now if we want to consider dpij, so we are going to consider this nums j. So in other words, here if we interpret this as a dp, right? So dpij will be the GCD of subarray starting from index I and ending at index j, right? So then we do a check again. So if dpij, after we set it, we check it. So if this equals k, so we're going to increment this result by 1. And after this loop, we just need to return the final state of this result variable. So with that said, so this code forms a format of solution. So let's do a check first. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess for this problem, I would not elaborate too much on the solutions. So actually, there are many solutions if we take more advanced math. So, but for this problem, due to the problem constraints or assumption, especially the first item, so I'm going to content myself with this current solution format. So with that said, I guess that's about it for this video. Thank you.